It's also called an equivalence point. Okay, so the definition of neutralization, sorry, the spelling is weird there, is the point where an acid and a base have reacted so that neither is in excess. An acid and a base has reacted and so that neither is in excess. Okay, also defined as the equivalence points. Please just bear in mind here, it says acid and base so that neither is in excess. It doesn't mean that the hydroxide ions have to equal the hydronium ions. Okay, so that's very important here. Just the acid and the base have reacted. Okay, so you'll see it as we go here. So as seen in the previous page, acid-base reactions produce a salt and water. So here I've given you what are we going to predict. So predicting what acids and bases make up a salt. Now I want you to change your thinking now. From now on, for a little while, we are not going to talk acids and bases as such. We're going to talk mostly about salts. Okay, so we've looked at some of the reactions with acids and bases already. And so we've seen the hydrolysis of an acid and a base. We've seen what acid and a base does. And now we are done with that. We are now looking at, well, after the acid and base has reacted, we now have a salt. And you've seen the salts that we've used in grade 10, for example, when we did precipitation reactions. Those are salts. And so now we've got these different salts. And we're going to say, okay, well, can we go back to see what type of acid and base came from there? Now, this is not going to be tricky, okay? This is not going to be something that you don't know, unless, of course, you know what I'm going to say, they have enough information that you can figure it out. Okay, I'm trying to get this shadow out of the way. It's not working. I don't think it's too bad. Anyway, okay. So here, for example, I have Na and Cl. So I want it to be quite obvious to you. And if you're not sure, have your list of acids and bases with you. Okay, if you're not sure where it could come from. So Na plus and a Cl minus. Okay, have a look at that list. Where do we normally get Na from? We know it's usually, it's possible acid and base where the ions come from. We usually get it from NaOH. Okay, and we are looking, sorry, I need a different pen here. Okay, NaOH. And here, where do we normally get the Cl? We get it from HCl. Okay, so one must be an acid, one must be a base. Okay, now tell me, can you see that this is strong and that is strong? Very important to realize this. Okay, let's look at this one. Ammonium and chloride. So we know that this would come from ammonia and HCl. Again, look at this. A weak base, but a strong acid. Okay, take note that the cations come from base and the anions come from the acid. Okay, that's because of the OH. The hydroxide usually comes from the base, so that's the negative. So that means the ion, the positive ion from the salt comes from the base. And the H here is positive, which means the negative in the salt comes from the acid. Okay, so here I've got K2S. So where do we normally get that? We get it from KOH. And S would be then H2S. So that is a weak acid and a strong base. Okay, so now what happens is that if I take these salts, okay, we're looking at the salts, and we dissolve them in water, hydrolysis happens. Okay, and now we're going to move on to hydrolysis of a salt. It's the reaction that salts have with water. So please don't get confused here. A lot of kids get confused here when they think of acids and bases. You've got to be able to identify your salt. Okay, so definition of hydrolysis of a salt is it's a reaction of an ion from a salt with water. So this is very important what I've done here, because I have divided or dissociated these salts, and they'll always dissociate into their ions. And then I've actually kind of come up with what acid and base they come from. But if you look carefully, we get an OH generally. Remember, ammonia is a little different. And we get the H. and that is the water, essentially. Okay, so because of this reaction, the pH of the salt solution, sorry, I must try to keep watching what I'm doing here. Because the reaction, the pH of a salt solution can be determined. Now, like I said to you, be careful. Neutralization doesn't necessarily mean for one hydroxide you have one hydronium. It just means that the acid and the base react so that neither is in excess. Okay, so let's see here. Example. Is an aqueous solution of sodium ethanoate acidic, basic, or neutral? This is a salt. Okay, how do you know? Because it has the sodium on here and not the hydrogen. Oh gosh, take a look there. Sorry, that hydrogen shouldn't be there. Okay, explain your answer with reference to the interaction between the ions of the salt and the ions present in water. So I'm going to show you a longer version on how to explain this, but I'm going to also give you a quick inspection method. This you can use for multiple choice, or if it's just like a 1 mark or 2 mark question. Okay, so here is our salt. Okay, now if we divide our here we have positives underneath each other and negatives underneath each other. So my positive ion is sodium and my negative ion is the ethanoate. Okay, and now remember it's reacting with water. So we know water is going to divide into hydrogen ions and hydroxide ions. Okay, now we're not going to use the hydronium ion here, because the hydronium ion is what is made when an acid is added to water, or when water self or auto-ionizes. Okay, so that's not what happens here. Remember, what happens here is water breaks up, because this is a salt, not an acid. Okay, and so we see that water breaks up into hydrogen ion and a hydroxide ion. And now if you look here, here we have NaOH, and here we have ethanoic acid. So we can see this makes a strong base. What do we know about a strong base? It nearly all completely dissociates. So they nearly all just stay as NaOH. Okay? But in this weak acid, we know that most of it will stay as the molecule, and some of it will divide into the 2 ions. Okay, so most of it will be like that, and only some of it would be like that. Then this would then make your H3O plus with another water. Okay, so if you look here, we know we're going to have the same concentration because the salt is the salt and it's 1-to-1 here, but we're going to have a whole lot more hydroxide ions because they've nearly all dissociated. Whereas here, the acid, only some of it has ionized to break apart the hydrogen ion and has made the hydronium ion. So we are going to have more hydroxide than hydronium when we have a salt like this. Okay, and that then tells us that we have a weak base. The salt is a base. Okay, the salt, please remember, we're not looking at acids and bases, we're looking at salts, but the salts can create those acids and bases when put into water. Okay, so again, you can look at it like this and go, oh, well, that's a strong base, that's a weak acid. So it must be basic because we have more hydroxide because this is a stronger base. That's it. Okay, so to determine the pH of the following salt solution, so let's take a look. KOH, okay, that comes from that. HNO3, that comes from that acid. So we've got KOH, HNO3, strong. This will be, oh my gosh, neutral. Sorry, I must just put an N for neutral. Okay, this KOH, this H2CO3. We know that the carbonate, hydrogen carbonate, is weak. Weak acid, strong base, it's base. Okay, it won't be very strong. It'll be a weak base, but still. Okay, calcium, because this is the positive, it must come from a base, so it must be probably that. Hydroxide, you can always actually put a hydroxide, unless it's an ammonium, then you know it's ammonia. And this will be an HF, so you can pretty much put your H's with your negative and your OH's with your positive ion. So this is weak versus strong, so this will be acidic. Okay, Cu, so again, CuOH, probably a 2 there, and this is SO4, H2SO4. Okay, so strong acid, weak base, it's an acidic salt. Okay, and then lastly, we have ammonium chloride. Let's do it without doing that. We've got a weak base with a strong acid, because this comes from ammonia, this comes from hydrogen chloride or hydrochloric acid, and so we're going to have an acidic salt. Okay, sorry, I made a bit of mistake and had to redo this part. So I'm going to start again with this. Well, for you, it's not again. For me, it is. All right, so I'm now going to show you when you have a neutral salt, an acidic salt, and a basic salt, what exactly happens over here. Okay, so the first salt I'm going to show you is NaCl. Now, NaCl we know is a neutral salt. So let's see here. We know that the cation comes from the base and the anion comes from the acid. So cation is going to then come from what? NaOH, sorry, it's the base. And then we've got HCl as the acid. Okay, so what I'm going to do now is I'm going to show you what happens. So I want to show you what happens when you put just salt added to water. Okay, what it looks like almost on a atomic level. What happens in an intermediate stage. Okay, what could then occur? I want you to think about it like that. It's not technically very scientific, but it's a way for you to imagine what's going on. And then obviously finally what's going to happen in the end of the solution. Okay, so if I have 4 water molecules, so I'm going to do 1, 2, 3, 4. And I'm going to do the hydrogen, the separate colors. Okay. I might not have to draw this all again. All right, so Na plus, so we're going to draw now 2 of each one of these. What's a good color to use? Purple. I don't know how it's going to look for you. Okay, Cl minus and Cl minus. Now remember, there's a water, and you've now put the salt in water, and the salt has dissociated. Okay, because salts do that. Now what could happen now is I want you to imagine now I've got water molecules, okay, happily around, but some of those water molecules are going to react with those ions we've just put in. Okay, so you can imagine Na, because it's positive, is pulling the water molecule apart and is now going to have OH. Okay, so we took one of the oxygens and one of the hydrogens to make it NaOH. Why? Because we knew it came from that base. Okay, and I'm losing 2 of my water molecules because I've got 2 of each of these. So Na again, and we have OH. Okay, and then also what happened is that when the OH was pulled away from the water molecule, we had an H left. And what do we know about that? We know that it would be with Cl because the H is negative. And so we have an HCl and an HCl. Okay, so I kind of wish like I had have done this before, and then I just talk you through this, but I suppose you get a chance to do it as well. Okay, so what happened now is that I had 4 water molecules over here. I've only got 2 now because 2 of these water molecules have reacted with the ions that we put in from the salt. Okay, so the water broke up. So if you take a look at that there's H2O, and it broke up as a hydrogen ion and a hydroxide. The positive hydrogen ion was then bonded to the Cl, which was negative, and the negative hydroxide ion bonded to the sodium, which was positive. Now, if we have a look what we've got here, we know that we have an acid, a strong acid and a strong base. And what do we know about those? We know they dissociate nearly almost completely. So we're going to just dissociate them completely. So we've still got our water molecules, okay, because now the acid is in water, and wrong color. The acid is in water and the base is in water, and so we're now going to have Na ions floating around. We are also going to have OH minus floating around. I know that looks terrible if the H gets the negative, but anyway. Okay, and we then have H plus ions floating around because they've dissociated from the strong acid and the strong base, and then we get our Cl's floating around. Okay, but then we know what happens here is that the hydrogen ion will then attach itself to the water using a dative bond. Remember the dative bonds, where both pairs of bonding electrons come from the water, and it's attracted to that side of the water molecule, making the hydronium ion. Okay, but it's okay to talk about the hydrogen ion being here. Okay, so that would end up giving you a hydronium ion. Okay, so that is what happens. So let's just go through here. Here we've got water. We put in salt. Okay, salts break up, they dissociate. They then react with the water, forming their acid and their base. Okay, and in this case we have a strong acid, strong base, and so they have both dissociated equally into their respective ions as the acid and base, leaving me with 2 hydroxides and 2 hydrogen ions, which would become hydronium ions, but it's okay to talk about the hydrogen ions. And so we have neutralized it, but not only that, we have made it so that for every one hydroxide we have a hydronium, and so our pH is equal to 7 because our concentration of hydronium ions is equal to the concentration of hydroxide ions. Okay, number 2. So let's take a look at what happens when you have an acidic salt solution. So here we have our base is obviously ammonia. 3, and our acid is HCl. So we have a strong strong acid and a weak base, giving us an acidic salt. Okay, so we're going to draw 4 molecules and 2 of each ion dissociated. Okay, so remember we're not looking at these yet, we are just looking at the salt. So we got our 4 waters again. Okay, I hope this makes sense. 4 waters. Okay, and we've got an ammonium floating around and another ammonium, and we've got our Cl's. Okay, and so that is what happened. We have ammonium chloride salt and we put it in water and they dissociate. Okay, so the next stage we're going to look at, here we have 4 water molecules. So this has reacted slightly different just because it's ammonia. Okay, so ammonia is going to land up being NH3 and NH3. Okay, now what do you think has happened to that one hydrogen that came from the ammonium? Well, that has now joined the chloride. Okay, so you add chlorides here. So water actually wasn't involved here at all. Okay, but now, if we have a look now, we are going to then see, okay, but remember this does not all ionize. This will completely ionize because it is strong. Okay, so, and remember I talk about ionize with ammonia because that's what happens with ammonia. The only base that does it. Okay, so we're going to draw 2 hydronium ions. I feel like I want to, I don't know what color to use. I think I want to just do this. Okay, 2 hydronium ions, and we can see what's going on. Hydroxide ions, we only get 1 of. Okay, now what I mean by that is that only 1 of these is going to ionize with the water. Okay, so you're going to land up with that, and we're going to have a hydroxide, and we're going to get 2 chlorine ions. So chlorine here is really a spectator ion, and we get 1 ammonium ion. And don't worry, I'll show you where everything comes from now. Let me just draw everything in. Ammonium. And then we still have 2 waters. Okay, I'm trying to draw it so that it's... Okay, so let's talk about what happened. Okay, so from here to here, because of the ammonium, okay, ammonium didn't really do anything. If you have a hydroxide here, you would do the same thing as we're going to do here, okay, or yeah, we're going to do the hydroxide here, okay. Remember, all the other hydroxides work the same here, where they're going to ionize and break up into their OH minus and their whatever their metallic cation is. So over here we got 4 waters. We've now got our molecule of hydrochloric acid, 2 molecules of hydrochloric acid, 2 molecules of ammonia. We know ammonia is a weak base, and we know hydrochloric acid is a strong acid. So both of those hydrochloric acids are going to ionize. How does it ionize? It gives water its hydrogen away. Okay, and I think water gets it rather than ammonia, because water is more polar than ammonia. It's got 2 lone pairs, where this one only has 1 lone pair. Okay, so the hydrogen will then attach to the water molecule, making the 2 hydronium ions. So 2 hydrochloric acid molecules making 2 hydronium ions, and here's our Cl's left over, and then just 1 of our, oh, I've got to draw an ammonia compound. Sorry. I'm just going to do it in red, NH3. So here, out of our 2 ammonia, we're going to only get 1 that is going to dissociate and ionize with another water molecule, because remember, that's what ammonia does. It ionizes, so it rips the hydrogen from water molecule, and that means it's left with a hydroxide. So now, can you see that we have 2 ammoniums to every 1 hydroxide? And now I also want to show you that it's neutralized kind of, because we used a 1-to-1 ratio over here. So but now, because of the reaction with water, the concentration of hydronium ions is greater than the concentration of hydroxide ions, and so the pH is less than 7. It is more acidic. Okay, last one, and we're going to try and do this as quick as I can. Okay, so here we have, and this is the one that I used before. So we have a ethanoic acid. So it comes from ethanoic acid, sorry. And this one comes from NaOH. I put them the wrong way. I'm sorry. You know what? I'm not focusing anymore. This has been a long lesson. NaOH and CH3COOH. Okay, well, this isn't an important part. This is important. That's why you get lots of cuts in this video. Okay, so we have water molecules again. 1, 2, 3, 4 with our hydrogens. Okay, I am going to do this again with you, where we talk about it in more detail and how I can get you to say it, to explain it in an exam. Okay, now what happens here is that we need 2 of each ion dissociated, so we are going to go CH3COO negative, CH3COO negative, and then we can have, I like the pink, so, and we can have Na. Please also again remember it's about the salt, not about what acid or base now. Okay, so now what happens, we get a reaction where we land up with 2 of our water molecules because we have 2 of each ion. Okay, so 2 water molecules, 2 molecules of acid, because remember 2 of these water molecules have broken up and the hydrogen went to the ethanoate and the OH went to the NaOH. So we land up with Na, I'm just going to do that, OH, NaOH. So the OHs came from the 2 water molecules, and my CH3COOH, CH3COOH. I'm doing it like this so you can see it's like a mixture. Okay, so here, if I had to do it in red, this H and that OH came from water. This H and this OH came from the water. So that's why we're only down to 2 waters. And now let's take a look. We have ethanoic acid, weak. We have sodium hydroxide, that is strong. What do we know about the strong? It's going to completely dissociate. So in the next one, we're going to land up with Na plus OH minus because it has dissociated completely. It's a strong base. And we have another one. Ooh, let me not do it there. Let me do it here. Put them on. Let me do it here. OH minus. I'm sorry. Okay, and then we have this one, which only one may dissociate, CH3COO negative, and that means we have 1 hydronium ion, because remember, it's now going to react with the water. So the hydrogen that comes off of the ethanoic acid then reacts with the water, and you get the hydronium ion. And then finally, and let me do it like that, we then also have a CH3COOH, which has not broken up, and it is, I'm not going to draw the waters here. So what has happened is one of these acids have stayed like a molecule, one of them has ionized, okay, because this is weak. And so it will only partially ionize. The NaOH is a strong base, so it completely dissociates. So there it has broken up, and we land up with some ethanoic acid that has not broken up, but yet if you look here, you've only got 1 hydronium, 1 hydronium ion to 2 hydroxide ions. That means the concentration of hydronium to hydroxide is less. Okay, hydronium is less than hydroxide, making this pH greater than 7. Holy cow, that was quite a lesson. I restarted this like 3 times. Okay, so I hope that helps. The task is going to be quite quick and brief and easy. Okay, so don't stress too much. I will go through this again where I explain to you how you can explain this. And I'm going to give you step-by-step steps on how to explain. Okay, so yeah, I hope you understand. Maybe watch it again. The whole idea is that you have in a neutral salt, because it comes from a strong acid and base, you get a pH of 7 because the concentrations are equal. When you get a salt that comes from something strong and something weak, the something strong will completely dissociate or ionize, and the weak will not. And so whatever one comes from the strong will be that substance. So if you get a strong acid with a weak base, you'll have an acidic salt. If you get a strong base with a weak acid, you get a basic salt. This doesn't happen with weak and weak. Weak and weak because it's very much some of it will because of the equilibrium that it would reach. Both as both ions could reach a different, an equilibrium. So I suppose you could work it out in terms of using the Ka value with a weak and a weak. But it's easy to see it with a strong and a weak, because you know that is actually what will happen. But a weak and a weak, you don't know to what extent they're going to dissociate or ionize. Okay, I hope that helps. We can Google Meet if you want to.